Hi, everyone. Welcome to this special edition of the Galaxies SIG seminar. I'm Aaron Young, and then I'm joined by Benny and John and, and a few of our friends here. And also, of course, Peter is going to tell us about the ASTRA initiative. So this is a call for mission concept, and Peter is going to give us this little introduction to what's being solicited and also perhaps some tailored message for the folks in the Galaxy Science Interest Group. So Peter, take it away.
Right. So, thank you, Aaron, for having me here. Thank you for that introduction. If you don't know me, my name is Peter Kurczynski. I serve in the Cosmic Origins Program Office as a Chief Scientist, and I'm here today to talk to you about the ASTRA initiative. And I don't have slides to share with you. This is going to be a bit of an informal discussion. I do have some websites that I'm going to share with you to give you timely information. And then I hope that we can have just kind of an informal Q&A discussion and maybe even some brainstorming about new mission concepts. ASTRA was launched this spring by the Astrophysics Division at headquarters, and the reason is to solicit community ideas and input for new strategic mission concepts. A strategic mission within the understanding of NASA astrophysics means a large mission. Think the James Webb Space Telescope, the Hubble Space Telescope, Roman Space Telescope. And these missions take many years to plan. They require a large base of astrophysics community support, and they require strong endorsement by the National Academy's decadal survey, typically. And we are at the stage in the 10-year decadal survey process where we're starting to think about the next decadal survey and providing inputs to that decadal survey. And this ASTRA initiative can be thought of as sort of the early stages of contributing to that. So in this initiative, NASA is throwing open the ideas to the community, saying, please share with us what you think the next big strategic mission should look like. What science should it address? What are some of the technology issues? What should it look like? Broad conceptual ideas at this stage, not detailed mission design. And that's what the ASTRA initiative is calling for. So this is being done in conjunction with a charge, you might say, to the program analysis groups, including Cosmic Origins, in which there will be a systematic kind of assembly of those concepts and kind of presentation, discussion of the concepts at a September workshop. This is the Ad Astra workshop, which you might be hearing about, and I'll provide some links to it in just a moment. That workshop will take place in September in Pasadena. And then following the workshop over the course of the fall, the Program Analysis Group Executive Committee chairs will be assembling all of the ideas and so forth, collating them and delivering them in some form to headquarters at NASA. NASA Astrophysics Division will then assimilate that information and then come back to the community in January at the AAS meeting with its assessment of how best to pursue these mission concepts going forward. And at that point, we anticipate that there would be some funded studies to further develop mission concepts that would then form as inputs into the next decadal survey. If you're familiar with the ASTRA 2020 decadal survey, the last decadal survey, then you may know that NASA did a broadly similar preparation for that decadal survey, in the sense that in the years leading up to ASTRA 2020, NASA paid for and commissioned 4 large studies of mission concepts, and those mission concepts were then kind of delivered to the National Academy's Decadal Survey Committee, and they formed as key inputs that provided context for what came out of the ASTRA 2020 Decadal Survey. And although those 4 concepts were not directly kind of endorsed by the Decadal Survey, a lot of the work that went into them was incredibly important and influential in articulating what has now become the Habitable Worlds Observatory and the broader kind of multi-decadal plan for astrophysics. So all of that is to suggest that even though these mission concepts might be early stage, early ideas, and so forth, they are ultimately part of a process which is tremendously important for the future of astrophysics. And that's why we'd like to encourage you to become involved in this process. So I see Aaron's put into the chat some of the links that I was going to prepare for you as well. So he's going to step ahead of me. So you can go to those links and find information about the ASTRA initiative. We have a Cosmic Origin landing page for it. You can also find information about the workshop, how to register for the workshop, and so forth. And then one more link that I'll put in is the text of the ASTRA initiative as it was released by headquarters earlier this spring. So if you actually want to see the raw text, if you like, you can go back to that document. So that's the overall context. That's what ASTRA is. The Ad Astra workshop taking place in September. And now, as I mentioned, we're encouraging the community to be thinking about what new mission concepts would be interesting. And in particular, since this is the Galaxies Science Interest Group, galaxies are kind of, at the very center and occupy the sort of the bulk of cosmic origin science in one way or another. And so galaxies will feature prominently in the future of astrophysics. And we would sort of ask you for what are the key questions about galaxies that we can anticipate answering with new missions in the future, and what might those new missions look like. So you can think beyond Habitable Worlds Observatory. You can think of perhaps new methodologies, new technologies, and so forth. And I could talk for a lot more about thoughts and ideas, but really I'd love to listen to what you all think and what your ideas are. So with that, I'll just sort of turn it over to you and ask, do you have any questions? Do you have any thoughts about the ASTRA initiative? And then if you want to, we can leave some time for thinking more specifically about concept development.
Thank you, Peter. So to give people maybe a few minutes to look at the links and get familiar with what ASTRA stands for, I have a quick question. So in non-NASA language, I know NASA has different types of missions. There's Pro, Flagship, there are other ones, Max. Roughly, is there a range within which the ASTRA initiative is shooting for? Like, how big should my dream get?
I would say dream big, first of all. And if you want to put some numbers on it, the document itself calls for mission concepts on the order of $1 billion or more. That's what NASA considers a strategic mission.
So should my dream be driven by Galaxy alone, or should it be driven by technology requirement, or should it be encouraged to explore multidisciplinary science cases?
Yeah, that's a great question. Realistically, any large strategic mission is going to have a number of science goals. It's going to be transformative in many different ways for science. Just think about the Hubble Space Telescope or the James Webb Space Telescope. But that having been said, since this is the Galaxy Science Interest Group, I would suggest starting with the science. What are the really interesting science questions that we don't have answers to? Maybe that James Webb is revealing to us that there's gaps in our knowledge, and start to think, first of all, what is the state of the art in our knowledge? And then what would it take to achieve a breakthrough? Like, what would be a tremendous new, way of understanding whatever it is that you're thinking of? And that's a good place to start the process of thinking towards a new strategic mission concept.
Great. Any questions from the room? Let me just quickly ask. If not, I can add one more. So where does my dream fit within the NASA timeline? So Roman is launching imminently. We're not going to beat that, no matter what. Hep World is still over a decade away. So is this after Hep Worlds or somewhere in between Hep Worlds and present?
Yeah, this would not be Hab Worlds. So this would be a new mission concept that's different than Hab Worlds. And the way to think about it is to put it in the context of the decadal survey process that I mentioned before. So Probably your mission concept is not going to be, funded and implemented in the next year and the next 5 years. We are thinking sort of multi-decades, and it may be daunting to think on such a long time horizon, but if you look at all the major strategic missions, they have evolved over several decades. It's typically 20 years between early concept of something like the Webb Space Telescope and launch. So
I suppose this would go into the 2030 decadal and then be recommended and looking for
implement,
potentially with a very long lead time to after have worlds.
yeah, implemented in the
Right?
40s.
Okay. Good. John, go ahead.
Yeah, so from the sounds of it, right, I've had a chance now to read over the documentation. Thank you for linking that. It sounds like really, given the timeline, what NASA's looking for is just not quite a pipe dream, but a dream, an idea, something that can be studied, worked on, et cetera, but is not, over polished.
Yeah.
Okay. So that's the right read on that?
Early mission concepts, yeah.
Okay.
To put a little bit more specificity on it, there is this rubric called concept maturity levels, which is becoming adopted as a kind of best practice for the way we think about mission concept development in astrophysics. And this concept maturity levels is a scale from 1 to 9, where concept maturity level 1 corresponds to basically sitting around the table and coming up with a cocktail napkin description of what a new space telescope might look like. And concept maturity level 9 would be, something that's on the launch pad ready to go. And what we're looking for is concept maturity level 1, concept maturity level 2. And concept maturity level 2 is a little bit more than a cocktail napkin. It's where you start to say, okay, we've got the notion of an idea. Can we begin to bound what its feasibility looks like? Are we limited by the laws of physics? Are we limited by, materials simply cannot be made to produce this space telescope or something like that? We'll start to bound it, but we're not going so far in the analysis that we can say, okay, it's going to cost this much and it's going to, weigh this much and it's going to have this much power requirements like that. And then the goal of the ASTRA incubator program, which is what NASA would fund next year and beyond, would be to take those early concept ideas and now do the real engineering work and the science and technical work to sort of define them quantitatively.
So I'm actually scrolling through the template itself. I don't know if maybe at the end we have time we can get into the specifics, but Benny, go ahead with your question.
So this is something that I struggle with as a junior folk, and I'm actually still struggling with. How do you get involved in one of these larger collaborations, or like how do you know who's working on what? And so especially if you're in sort of the smaller institutions where I'm at, if there's something like who's thinking about a UV mission, who's thinking about gamma ray, the next level gamma ray mission. Is there some sort of forum or basically saying, hey, I'm interested in this. I'd like to do this. This can be my contribution. I know this sort of happens organically, but that also means it happens often local, in the room. Yeah. And so how do I get in the room as a junior person or senior person in a small institution?
Yeah, that's a great question. And I would say that one of the kind of overarching goals of this ASTRA initiative is to make it easier for people who are not kind of insiders in the NASA world to participate. And most directly, I would say one of the ways is to register for this workshop and to attend the workshop, because that's where you'll find out what other people are thinking of. And if you want to be involved in a mission concept that might be submitted to the workshop, that's another great way. Then first of all, you can submit an idea yourself and just upload it to the submission form. And ultimately, what will happen is that the program analysis groups are going to be aggregating sort of similar concept ideas together. And so through that aggregation process, you will naturally be swept up into the stream of people who have similar ideas. And then you'll find yourself undoubtedly in the room when that concept is, discussed at some larger level, either at the workshop or beyond. And if you feel intimidated about submitting a mission concept idea yourself, then I would say, talk to me or talk to other people in the program office, and we might be able to pair you up because we have some idea of what other people in the community are working on, and we can make introductions and so forth. We'd be happy to help you to do that. So those are just some ideas. I think probably the most important one would be to just be aware of the workshop itself, and if you can, try to register for the workshop. Yeah, John.
Go ahead, John.
Yeah, so just following up again on the document. So it seems very intentional, right? This message of fiscally constrained environment, right? And I think we're all aware that of reducing that by partnering with other industry partners, et cetera. But what are some of the less well-known ways of reducing mission cost that we may not be as exposed to as people working on sort of the science end?
That's an interesting question. That topic was one of the main topics of discussion at this innovation workshop that took place last week here in Washington. And I mean, I could answer the question and give you some detail into some of the ideas that people have come up with in terms of ways to reduce mission cost. But I think from the purpose of this ASTRA initiative, I wouldn't worry too much about the cost of your new mission idea, because yes, you want to have some general notion of cost of a new mission concept, and the way you develop that notion at CML2 is to just think of what other missions look vaguely similar to the idea that you have. And at CML2, that's all you need to worry about in terms of cost. But since you asked the question, some of the specific things that people are thinking of to reduce mission cost are things like bulk buy of spacecraft, where NASA purchases from an aerospace company a number of spacecraft buses, in which there can be perhaps some volume discount on the purchase, but then of course that commits the Astrophysics Division to using the same spacecraft maybe 5 times for subsequent missions. So that has trade-offs on what the science might be constrained by that. But that's just an idea of one of the ways that spacecraft costs might be reduced. And it's also worth pointing out that we kind of anticipate that there's going to be increasing availability of launch vehicles, and launch capacity is going to increase in the coming years, and that may be a way to reduce launch costs or mission costs, because if the cost to orbit goes down, then that's translated into the overall mission. And then finally, we're talking a lot more about serviceability, and if you can have spacecraft that are more easily serviceable by robotic means, then that may present some attractive features that may translate into cost savings. Those are just some ideas. There were others. There was a whole 2-day workshop on this subject last week, and there will be a report of that workshop coming out soon.
Fantastic. I look forward to reading it. Thanks.
Yeah.
Great. Go ahead, Alexandra.
Hi, Peter.
Hi.
You mentioned the decadal 2020 preparation activities that NASA did with the pre-decadal studies for both flagships, but then sorry, my dog's barking. I'm not sure if you can hear. But you also, they also did they also solicited white papers for probe scale things. So there's a lot of, I guess, studies that are already going. How are those going to be folded into this process? Are those, people who worked on these before resubmitting them, or is that somehow already part of the conversation?
That's a great question. I would encourage people who are on probe studies to just fill out the ASTRA template with their probe mission concept, and then make sure and use that as a means to make sure that it's back in to the ASTRA initiative. It would take, if you've gone through the work of a probe study, filling out the ASTRA template is going to be a no-brainer, I would think, and it would make sure that your probe idea stays current in the new discussion. But it's not going to happen automatically, if you see what I mean. It's not that all the probe studies are going to be automatically grandfathered into this ASTRA discussion.
Sorry, just to follow up as well. Will the process down the road for NASA, so this is the first step where they're soliciting sort of broad ideas, and you said there would be some efforts to kind of combine things and pare them down. Is the plan to do a similar thing like they did for 2020, where they solicit, STDTs to work on these studies, or is there a different plan?
Sort of, yeah. Like the analogy to the STDTs from ASTRA 2020 would be the ASTRA incubator studies, which would take place starting next year. So whereas ASTRA 2020 had these 4 large STDTs, and they culminated in the 4 mission concept point designs and so forth, and probably you're familiar with them. In this case, there would be some focused study, a funded study that would explore the mission concepts more fully, but it would be done a little bit more. It would be done a little bit differently than the STDTs from ASTRA 2020, basically using lessons learned from that whole process. But that's what would start ideally next year, and would be announced at the January AAS meeting.
Okay, great. Thank you.
Great. Thank you for that question. Any other questions?
If there are no other questions about ASTRA, I would love to just take the opportunity that we have here to ask you all about Galaxies, and what are the big exciting questions about Galaxies that you're talking about, that especially in the light of Webb and so forth. What are the unsolved questions from the decadal survey that you think are the most current, and how are we going to answer them?
There's a few. I can think of a few for Galaxies. With Webb, we're sort of still pushing for the population 3 object, or anything that is dominated by population 3 stars. I fear it might become a little bit more white whaley than we would hope, but because you have to prove absence of evidence, or provide evidence of absence, sorry. And so that's going to be a tricky one. But I think that is something that we'll get a lot closer to, something very similar to, or analogous for habitable worlds, for basically planets, to see biosignatures, right? So you can always say, like, we found methane. It's like, well, that could be volcanoes, sorry. That could be anything. There's multiple ways to get there. I suspect down my own rabbit hole is the fact that there isn't as much structure in Galaxies as we see locally, and that is strange. I don't think it's completely out of the realm of simulations. We can ask Aaron about that, but the fact that you don't see as many spiral arms, bars I get, but other structures, they seem remarkably smooth at high redshift. So that's something to follow up on. That'll be something that Roman will do. So this is the kind of thing, like, I can see the next thing that's being launched answering some of these questions already. So I think a lot of the questions that we're getting are only going to show up in a few years' time as well for the local Galaxies. I think so. Those are 2 things that I'm curious about at the moment. When did the first stars get made? I'm very curious about when the first ISM really gets enriched. So you can see the difference in dust from silicates, because that's coming from supernova versus AGB stars. do you see it arrive in different generations of galaxies? So that's the stuff that I'm interested in. I'm sure there's completely different answers in the room already. I know that Jason is here, so he'll give you an answer about low surface brightness universe, which isn't actually fully discovered, or that's we're getting with Ruben. So there will be a lot of things that we can follow up, I think, already. So there's interesting things just around the corner. I think longer term, I think we've run out of candidates for what dark matter can be. So I think there's something there, right? That you expect something to happen sometime, but that's what people have been saying for the last 40 years. So I think that's a good thing to pontificate, because you can never be wrong. Either somebody does solve it, or it's like, well, we're just around the corner. So I'm hoping that doesn't become, the fusion of our time, over our subject anyway. So learning more about that would be, I think because we're going to get lensing at scale, we'll actually learn more about that. So we'll actually get more data.
Mm-hmm. Yeah, I would think dark matter would be a prime area where there's a need for new data, isn't there?
Yeah, so this is not my subject, but just sort of looking at what the evidence is for dark matter annihilation, for example. You've got Fermi-LAT at the moment, and judging from the nearby galaxy stacks, etc., they was sort of like, it's not a particle of that particular, GeV mass. So I think X-ray and gamma ray astronomy, or sort of concept missions, will probably start saying, like, look, we're going to go drill down, because that's the level of sensitivity we need to get to know what dark matter is. So if I had to pontificate what kind of mission concepts you're going to get, there's going to be a high energy one that's going to look for annihilation signature, for example. So
Good.
Not trying to stray into other areas too much, but that's for what galaxies are made, like, that you need to know what that stuff is, right? So
Yeah.
Aaron's smiling, so it's
I'm going to drag everyone back into galaxy. So I care about the first galaxies and how they become the one that we live in today, like the whole process, the whole evolution. Now it gets me. GWS is great. I love it. This is like what might be my career on, but knowing that someday GWST will run out of coolant, will run out of fuel, just makes me nervous. And given how long the lead time is and how long it takes to develop a big mission like that and the technology, I think this is like, we're a little late, but we should start now to think about its successor. We need this high resolution, high sensitivity infrared window that we can look at. So back to ASTRA. Peter, this is a question for you. How crazy it is for me to propose to put a telescope on the moon?
Not crazy at all. I think you absolutely should.
Yeah. Right. I mean, it's crazy enough that I think it will be an interesting thing to add to the NASA portfolio, but also to not send another 6.5-meter telescope to space and never be able to service it or never be able to take it apart. I think building a 6.5 and bigger telescope in the moon that doesn't have a thick atmosphere that absorbs all the infrared might be the way to go for the next thing.
Yeah. Yeah, there are people who are actively exploring that. There was a NIAC-funded study on optical telescopes from the moon. It's in a project called the Artemis-enabled stellar imager, I believe, or maybe that was an interferometer. There's a book on the subject by Joe Silk called Astrophysics from the Moon, and we have groups at NASA that are forming now to explore astrophysics applications from the moon. So if you're interested in that topic, absolutely, we can get you in touch with people who are exploring it from the scientific side, or from the scientific community side.
Thank you. Great. Jason, I see you turn on your camera. We don't seem to be able to hear you. Maybe your mic is... Yep.
So you were thinking of a near an infrared?
Or if we can go out to meet, it would be great.
To what?
To meet infrared, it would be great.
Mid-infrared?
Right. Yeah.
Is there any like contamination from emission from the lunar surface? I guess it gets quite cold during the lunar night, but a normal space telescope can operate during, as long as it's not pointed at the sun, and during the day the moon gets quite hot.
Yeah. Yeah. What about the permanently shadowed region?
Yeah, I think that's the key. Like on the lunar surface, if you're in a shadow, it's extremely cold, and there are definitely regions where it's permanently in shadow. So there's some variation in terms of what the thermal conditions are like. Exactly.
I guess then by definition you've ruled out observing in the ecliptic plane though. But if you're a galaxy person, that's not a big deal.
Well, ideally, I want to be able to look at anything I want to. So not be able to look at certain things is still a huge bummer. I guess L2 it is.
Yeah, I guess the larger question is free flyer versus lunar surface, and what are the pros and cons? Serviceability, in principle, is an advantage of being on the lunar surface if you already have people there for Artemis after, and potentially larger apertures on the cost and so forth, and the assembly method. But free space does have a lot of advantages, and there's a cost to getting things down to the lunar surface in the same way that there's a cost of getting things off of the Earth into space to begin with, and so that has to be factored in as well.
I guess in terms of the cost of getting down to the lunar surface, I know the Lunar Gateway Station has been essentially scrubbed, but is there any chance of reviving that? Because for certain destinations, that would reduce the cost a lot.
Yeah, I don't know. That's not so much a science question as an exploration question.
Yeah.
Go ahead, John.
Yeah, and so this isn't so much a science question either, but Peter, you're bringing up the idea of serviceability, and I just want to get a sense of what that sounds like, or what is currently thought of as feasible, because to my knowledge, that hasn't actually been done in practice. So are we talking about L2 serviceability, or are we thinking more like moon-based serviceability, LEO? What's the state of the art for that, and what would we be able to reasonably expect to set up to facilitate that, given that there's no practical examples out right now?
Yeah, that's a great question, and this is an area where there's tremendous advance, and the state of the art is advancing very quickly. So missions like Habitable Worlds Observatory are being conceived even now with the idea that they will be serviceable at L2 robotically. So that's what people are actively thinking about for Habitable Worlds Observatory. To give you an idea of where the state of the art is, as one very timely example, the SWIFT mission is going to be serviced with a reboost. Hopefully that will be successful, and that mission is going to be launched over the summer to hopefully save the SWIFT spacecraft from orbit decay and reentry. There will be a spacecraft that's going up. It's going to rendezvous with SWIFT, grab hold of it, and push it up to a higher orbit. So that's an example of serviceability. And the same thing has been contemplated for the Hubble Space Telescope, although there's not an active plan to do the same thing for the Hubble. But people have thought about it, and it might be revived in the future, depending on the outcome of the Swiftly mission to reboost Swift. Now, as you delve more into what has been done in the way of serviceability, in the commercial space world, telecom spacecraft have been serviced robotically at geo orbits. That has been done. And In fact, one presentation that I saw not too long ago from a aerospace company showed that a telecom satellite was serviced robotically at geo orbit, and the presenter said that during the whole time, the satellite was still functioning and processing over 1 million telephone calls while it was being serviced. So that is the state of the art, and it just hasn't been done in astrophysics.
Okay, thank you. That's very encouraging.
So this brings up an interesting sort of spin-off question. Partnering up with the industry, is that something that we should bake it in now in this stage, or just mention it and hopefully in the future when the mission develops, then we'll think more about that kind of thing?
Right now, absolutely, because the commercial space is evolving so rapidly that this is one of the kind of raison d'etre for ASTRA initiative, and that is that we would like the scientific community to be as aware as possible and using as much as possible these advances that are happening in commercial space so that we leverage them for science. And, as an example of the way NASA is trying to do that, there's this CLIPS program, which is a commercial lunar payload services in which NASA is kind of partnering with aerospace companies, in some cases small companies, to deliver payloads to the moon. And you've seen some of those launches. They've had some mixed success so far. They haven't all been successful 100%, but some of them have been successful, and there's going to be more of them going forward. So if you have any ideas that make use of new commercial capabilities, that's absolutely going to be very interesting for this ASTRA initiative.
Great. Any other questions from the room?
So I recall John Grunsfeld being like a really pro construction in space. So this would be a thing around the International Space Station. This wasn't so much look at all the astrophysics we could do, because I think it would be a relatively small telescope in space, but effectively, can we launch a telescope in pieces and then put it together? And so that was not so much serviceability, but it was sort of an interesting Venn diagram of new astrophysics, but then also new capabilities for astronauts to make things. And so, I don't know, is there a sort of is that what would be a reasonable thing to say, like, hey, we're going to make a little robot that's going to dig a telescope on the far side of the moon and make a radio telescope there, mostly made out of the materials that were already there. So the nice thing about a radio telescope is that you can just put down rebar and you'll pick up a signal. And so it doesn't even need to be, it has a high level of fault tolerance. So this would be something that a robot could build. This is not this is such a known concept that I think it actually made it into science fiction, right? So on the far side of the moon, there's a radio observatory. And it's like, well, maybe it's now time to go build that radio observatory. So I was kind of curious if so since it's CME, or was it concept mission level CML2, this is I'm just positing a robot, because robotics are hard to figure out where we actually are, and then say, like, hey, what would we be able to do with an interferometer or a just single large dish on the far side of the moon?
Yeah, and exactly what you just described has been actively studied.
Okay.
There's a project called Farside, which is to deploy an array of dipole antennas on the moon, and there are various stages that they envision for the project. And the first stage is pretty simple in the sense that dipole antenna is just a big long wire or a whole network of big long wires, and you just roll them out, sort of thing. But then on the larger scale, you need to do some, what's the phrase, in situ resource utilization. So you need to learn how to make radio antennas out of lunar regolith or something. And there has been, thought put into that. So yeah, definitely. And you mentioned interferometry. I think that's another area where it may be the case that the changing economics of space access could really enable interferometry for science in a way that hasn't been practical in the past. If you reduce the cost to orbit, you can now maybe envision launching, huge swarms of interferometric nodes, and now you can disperse them widely and achieve very long baselines in space. What advantages would that have for science? Imagine 10,000 6-inch telescopes scattered throughout the universe, scattered throughout the solar system, rather, and imagine that they're linked by optical communications so that you can get, very precise baselines. Could you envision doing interferometry at wavelengths, maybe optical, maybe not optical, maybe far infrared, or maybe sub-millimeter, say? And people have already thought about quite a bit about the sub-millimeter interferometry in the context of the Event Horizon Telescope. So yeah, those are all like interesting things to play with.
Another thing, well, it's not Galaxies, LIGO and the pulsar array, timing array, for example, like looking at gravitational waves is another one.
Yeah.
But that's where we are getting closer to what is interesting for galaxies, which is merging supermassive black holes, right? So this is the part where you have galaxies merge. This is happening at, cosmic noon, so redshift 2. And you expect supermassive black holes to be merging a lot. And so you should see the underlying noise of the gravitational waves basically from that happening. I think that's what LISA is for. And I think there was an excellent reason to go into space and not do it on the moon, because the moon does have a little bit of quakiness to it, right? It's still being actively. So yeah, these are things where like you have to start doing ballpark estimates of their noise levels and figure out where it's the interesting thing to do. I did notice that there's a fair amount, like there was one UV telescope deployed by the Chinese, but I never saw a picture from that. That would be another thing to put there, because again, ultraviolet is hard to achieve anywhere else. It depends on how much astronaut presence there is, for example. Like, is there, I think the reason that John Grunsfeld wanted to use the ISS, because he said, like, well, we already have the Wi-Fi up, so we might as well have a telescope send information down from the ISS. And this was after the ISS was discounted as a good platform for a telescope because it was too shaky and there was too much atmosphere around it. And I think that's sort of, these rethinks are pretty useful for that. But it does help if we had more of an idea what the napkin for Artemis would look like. So what will be available on the Artemis moon base? What can be brought? What's a reasonable concept?
Right. Yeah. Now that we're thinking about Artemis and going back to the moon, all of these big ideas that we might be thinking of for 2 decades from now, they're going to have important precursors that could be done in the relatively near term. And you mentioned lunar seismometry and how that might limit or provide important background for other scientific measurements. So you can envision projects evolving in the next few years that would study that background. For example, let's launch some corner cube reflectors on the moon and beam lasers at them from Earth and use the return signal to do seismometry of the moon and measure that background and that might constrain what's possible scientifically. So that's a project that you could envision actually building and deploying in the next few years, because there are going to be missions going to the moon, and a corner reflector is not a huge ask in terms of technology development.
Sorry, trying to take notes at the same time. That's never, yeah, I'm trying to condense what you just said. I need to get the book Astrophysics from the Moon. Clearly, that's the next buy from Amazon.
Joe Silk was the author of that one. And there was also a conference several years ago that was held at Kennedy Space Center on the subject of astrophysics from the moon. If I can dig up the white paper from that, Bene, I'll be happy to send it to you. I'll look for it. And we have, in the program offices, we have a science interest group devoted to astrophysics from the moon, and you can certainly join that science interest group and get more, like-minded people interested.
Did not know we have that.
And
It's right now. It's planned through. This particular group is run by the Physics of the Cosmos program, but if we have enough folks interested in this topic from Cosmic Origins, we will explore how to set up our own group. And anybody can join any of these groups. It's not like we're trying to mark out territory here, but we're just trying to be responsive to the community's interests.
Great. Well, that has been an interesting discussion. Is there anything else folks from the room would like to add? If not, just to quickly remind everyone, we do have a seminar tomorrow at the same time. So do join us if you can make it. And I think we should thank Peter for joining us today to discuss ASTRA and what we can do with it. The deadline is in 24 days. So for those of you who are interested in putting something out, do it quick.
Yeah, and thank you all for all that you're doing. Thank you all for contributing your subject matter expertise and your talents and your creativity to NASA astrophysics. It's really a pleasure to be here. I look forward to talking with you again.
Great. Thank you. Let me stop the recording now.